Welcome back. In the previous lectures, we have discussed about the angular parameters, the two angular parameters which are the angular velocity and the angular displacement. In today's lecture, we will discuss another angular parameter which is the angular acceleration. In the previous lecture, we have already also discussed about the difference between the circular motion and the rotational motion. Please watch that videos before this for better concept. Now let's talk about another angular parameter which is the angular acceleration. Now let's define the angular acceleration. The rate of change of angular velocity is called the angular acceleration. Let's focus on the formula. Angular acceleration is represented by alpha, and alpha will be equal to the rate of change of angular velocity. Angular velocity is represented by del omega upon del t, the rate of change of time. Alpha angular acceleration, change in omega, change in angular velocity. Now note down that a body moving in a circular motion, if the velocity increases or decreases, in this case the angular acceleration will exist, while if the speed the velocity of the body moving in a circular path is constant, so there will be no angular acceleration. So if the body velocity increases or decreases in a circle, we say that the body possesses angular acceleration. In spite of, if the body is moving in a circle with constant velocity, so angular acceleration will be zero in this case. This concept is very important. Now the SI unit of the angular acceleration is the radian per second square, but it can also be described in the revolution per second square or the revolution per minute square. Let's talk about the dimension from the given unit. Dimension A is the unit of the angular acceleration is the radian per second square, and radian is a dimensionless constant. So radian has no dimension. So in the denominator there are exist per second square, so the dimension will be t to the power minus 2. For better concept, let's focus on the given formula that alpha angular acceleration is equal to del omega upon del t. Del omega has a unit of radian per second while del t has second, so only the formula that has a unit that has a dimension, that will be the second. Direction of the angular acceleration. The direction of the angular acceleration is always along the axis of the rotation or the torque. MDCAT set important facts ये है कि whenever the angular speed increases, the angular acceleration will be in the direction of the angular velocity and displacement. In spite of, if you move in a detailed topic, if the angular speed decreases, the angular acceleration will be opposite to the angular velocity. Now, thank you.